it here, boy. I'm gonna try something board, right? Right, morning online. Y'all seen it, y'all seen clearly there, right? Yeah, y'all seeing that? So let's take a look at matrices. That's good. So now you can teach me, right? Huh? All right. So let's go with matrices here. Where is my good marker, right? All right, ready? Ready? Sure. All right, so let's start with matrices. Oh, you can see from there and go down with it this way. I can see that. Huh? Right? Right. So matrices. So the first thing we need to know is how to name a matrix, right? So a matrix is, for example, a matrix like this: 1, 5, 7, 3, right? 1, 1, 5, 7, 4, 3. This is a matrix, and this matrix has 2 rows. And the matrix has 1, 2, 3 columns. Right? This, the way you name a matrix, you name a matrix by the number of rows, by the number of columns. Right? Number of rows by number of columns. Okay? So we have 2 rows and 3 columns, right? So here we have a 2 by 3 matrix. That's okay? Okay with that? Yeah. Let's just see if we can name these 2 matrices now. Right? Check those other 2 on the board and tell me what type of matrices they are. Right? What type of matrices are these? So you have 1, 2, 3 rows, 1 column. That's 3 by 1. This is also called a what? Column matrix, right? This is called a column matrix. And this here is a 3 by 3. There's a 3 by 3 matrix, also called a square matrix. Are you okay with that? Actually, you know what? I know if I'm on this summary, I have a whole thing. That will save us some time, you'll get more practice, right? All right, so watch this here. So if you look all the way down here, right, and this summary is in a group, right? So you don't have to write, we'll just focus on practicing more, right? So watch this here. So to name a matrix, right? To name a matrix, we name it by number of rows by number of columns, right? So for example, here we have 3 rows, 1 column, it's called a column matrix. Here we have 2 rows, 2 columns, it's called a square matrix, right? That matrix is also what? It's also the identity matrix. You recognize it? 1, 0, 0, 1. right? You have ones in it diagonal, 0 everywhere else, right? That's the identity matrix. Then here you have a row matrix. It has 1 row and 2 columns, and then you have a null matrix. Are you okay with that? Everybody okay with that? So you have a null matrix that's all zeros. Okay? Right. We need to be able to add and subtract matrices, right? The only way we can add a matrix is if these matrices are the exact same size, right? So take a look at A and B. Are they the exact same size? No. A is a what? Right? 2 by 1. Sorry, yeah, 2 by 1. And B is a what? 1 by 2. So we cannot add those, right? Or subtract them. But A and C, nice. How do we add and subtract? Real easy. Right? Real simple. If I give you 4, 5, and you have 7, 3, to add those matrices is simply add the 4 and the 7, add the 5 and the 3. So you're going to get 11, 8. Okay? Right? So try one for me now, please. 5 minus 3 plus 4, 2. Try that, please. 4 minus 3 plus 4, 2. Add those two matrices. Still tying up. Right? Try that pass. All your notes on the summary, just focus on writing down practice, right? All your notes on this summary. At the pass, let's do it here. So remember, to add, they must be the same size, right? Exactly the same size. Yeah, are in the same exact position. Yeah, it's conformable, yeah. Once you can add them, means it's conformable, right? So that'll be 5 plus 4 minus 3 plus 2. So that'll be 9 minus 1. Are you okay with that? 9 minus 1, all together? Yeah. Add this pass number here, 1, 7, 3 plus 0, 4. Add that, please. Xavi, add the thing now. You want the board? If you add that? I just give it there. You can have a next one there. Uneven. Right. Right. It's non-conformable, right? Right? We cannot add that because there's not conformable. You can't add 3 by 1 by a 2 by 1. Okay? So nice. You have a small idea. Do this then. 2, watch this here. 2, 1, 0 minus 5. I want you to subtract 5, 3, 4, 0. Actually, put a little minus, trying to confuse it here. Subtract those two matrices there for me. Are they conformable? Yeah. So we can subtract them, right? Go ahead. Right? You're subtracting the exact same positions, right? So you're subtracting 2 and 5 and 1 and minus 3, right? Whenever you do addition and subtraction, you're supposed to get back the same size matrix, right? Ready? Let's see what you got. So it's 2 minus 5, 2 minus minus 3, 0 minus 4, minus 5 minus 0. Minus 3, 5, minus 4, minus 5. That's okay? Are you okay with that? Come here. You okay with that? Right? So if you add a 2 by 2 to a 2 by 3, you're supposed to get a 2 by 2, right? Subtraction as well. Yeah? Top right. Wait, I write the wrong thing somewhere? Oh, sorry, I wrote 2. Thanks. It's 1 minus minus 3. Yeah, thanks. Right? So that's the way you add, that's the way you subtract, right? They must be conformable, which means they must be the same size. Right? Conformable has different meanings. I'll show you that's not right. Conformable means that it works for that particular function, addition or subtraction or multiplication, right? Right, so that's how we add, that's how we subtract, right? 2 quick notes. To add and subtract, the matrices must be the same size, right? And to add and subtract elements in the exact same position. Nice. How do we multiply? Let's start with the easier version. How do we multiply by a scalar? Right? This is A. You bring your K in front. So if I ask for KA, all we're doing is multiplying K by every single term. That's okay? That's the way you multiply by a scalar. You multiply K by every single term. So watch this here. If you have 4 by 2, 1, 3, 0, you're multiplying 4 by 2, you'll get 8. You're multiplying 4 by 1, you will get 4. 4 by 3, that'll give you 12. 4 by 0 is 0. That's okay? That's the way you multiply by a scalar. Everybody okay with that? Copy it down. Let's try one. I'm giving you a matrix A. A is 2, 1. And I'm giving you a matrix B minus 3, 4. I would like you to tell me what's 2A plus 3B. What is 2A plus 3B? Try that, please. So you have to work out 2A first, and then you have to work out 3B. Right, find 2A first, find 3B, and then add that, right? Right, who's making customer? That's who's going to live out of the influence. Yeah, we'll go to 2A. We'll go down and 3B, and then add that. Take your time to 2A first, and 3B, and then Was 2A. We'll work out 2A. Forget the question. We'll work out 2A. Oh. All right, ready? Let's see what you got. So 2 by A, so it's 2 by 2, 1, right? So 2 by A means you're multiplying 2 by 2, 1, and then you're multiplying 3 by minus 3, 4. Then you multiply it, then take your time, multiply it out. 2 by 2, that's 4. 2 by 1, that's 2. Right? 3 by minus 3, that's minus 9. 3 by 4, that's 12. Right? What's the next step? Your next step is to add it, right? So you add in 4 plus minus 9, and you add in 2 plus 12. Okay? So you'll end up with minus 5, 14. Okay? So that's supposed to be the easy part. Now for the hard part. Any questions online? Right, good job, Jamie, Caleb. Any questions online with this part of it, Tanya? Any problems? Harish? All right. So now for the hard part, right? I'll stay a little while on this part here because here's where people get problems multiplying matrices. All right. Right. Yeah, exactly. And that's the main story, row by column. Right. So look at the example here. We found 2A, we found 3A, and so on, right? All right, good. Let's take a look at the rules first. Let's take a look at the rules first. This is your summary, Elena. Check in my summary and you'll see it. Right? Good. These are the rules when multiplying two matrices. The first rule is if you have two matrices, the number of columns in the first matrix has to be equal to the number of rows in the second matrix. That's okay? Clear? Okay with that? So the number of columns in the first matrix have to be the same as the number of rows in the second matrix. And then if those things hold, it means that the matrices are conformable. Right? And then the second thing is that the product is going to be the number of rows in the first matrix by the number of rows in the by number of columns in the second matrix. So those two things are really important. You have to make sure the matrices are conformable. Then you have to know what your answer is. Okay? So I'm going to do that a few times here, right? But I'm going back on the board for this one because I want you to follow me properly. Follow me. Right. Let's start by identifying if these could multiply, right? Suppose I give you a, right? Just tell me yes or no. Suppose I give you a 2 by 2 by a 2 by 2. There's matrix 1, there's matrix 2. Can I multiply these two? Yeah, because these two values are the same. And what's the answer? The answer is a 2 by 2. Are you okay with that? Suppose I gave you a 2 by 1 by a 1 by 2. Can you multiply that? Yes, because these two values here are the same. And the answer is a what? 2 by 2. Right? Suppose I gave you two matrices that are exactly the same size. Suppose I gave you a 1 by 2 and a 1 by 2. Can you multiply these two? No, because these values are not the same. So they are not conformable. Right? Suppose I switch it around now. Suppose I gave you a 1 by 2 by a 2 by 1. Can you multiply them? Can you multiply them? Yes. These are the same, and the answers are right. But what you'll notice here? What's a 1 by 1? One value, right? What's a 2 by 2? How much values? 2 values. 2? Oh, number 2. Right? 2 by 2 is 4. 2 by 2 is 4. That's okay? So it's important that you know what size matrix it's dealing with. Are you okay with that? So let's try this one here. First thing you'll do is you'll simplify, multiply it, and then tell me what the answer is supposed to look like, right? Let us do one like this. Right. Look at the matrices. Tell me these matrices are conformable. What size is it? There's a 2 by 2. What size is this? Right, 2 rows by 1 column. That's okay? Yeah? So these values are the same. So therefore the answer is a what? So these two are the same, and the answer is a 2 by 1. Watch why this is important. Right? This is very important, right? It tells us that we're supposed to get 2 rows and 1 column. Right? So when we're done, we're supposed to get 2 values alone. Okay? So you finish phase 1. Phase 1 is being able to identify if they're conformable and what the answer is. All right? For those who write it, copy this down, and then we're going to look at how to actually multiply. Copy it down. We're going to take a look at how to actually multiply. This is copy down, and then I'm going to show you how to multiply. You know, go right there. Good. If we can do it right there. Right, there's probably only hard thing in matrices, except for having to remember the transformation here. All right, so we're going to learn to multiply now. Okay, down. All right, ready? Yeah. So we turn up ready. Right, so we're going to start to multiply now. Right, whenever you multiply, you always multiply rows with column. All the rows in the first matrix by all the columns in the second matrix. Right? Let's make a note that I'm always multiplying rows in the first matrix with column in the second. Okay, so watch this here. So watch this here. Watch here earlier. Right? So you're multiplying this row by this column. Always multiplying rows in the first matrix by columns in the second matrix. So you're multiplying this row by this column. So 2 by 1, 4 by 5. Right? Supposed to have equal amount of value. So you're multiplying this value by this value and adding it to this value by this value. So it's 2 by 1 plus 4 by 5. So you're multiplying 2 by 1 plus 4 by 5. So you're multiplying this row by all the columns. There's only one column here. Then it go again, right? And multiplying. So you're finished with that row. So you're done with that row, right? Now this row, this column. So you're multiplying this by this. So minus 3 by 1, 2 by 5. Right? Row by column. Minus 3 by 1, 2 by 5. That's okay? So it will be 2 plus 20, that's 22, minus 3 plus 10, that's 7. Right? That's the way you multiply. Are you okay with that? Click catch up. So you're multiplying row by column, right? When you're multiplying, remember is this value by this value, and stop. This value by this value, stop and add them. That's okay? Don't multiply this by this and so on. There's 2 by 1, you're done. 4 by 5, you're done. Right? Once you multiply this row by all the columns, you finish. Okay? Any questions online? Let's try one, right? Of course, please make sure it's conformable, right? Make sure you can actually multiply. Try that, please. Try that. Let's see if you get the answer. Right? You take for granted that it can multiply. Make sure it comes from the right, the reason I'm making it find the answer that I wanted to write it like this first, right? So you know how much values to get. All this live. Huh? All right. Let's check it out and see. So remember, it's row by column, right? So I have a 2 by 2 by a 2 by 1. These are the same. The answer is 2 by 1, right? 2 rows, 1 column. Minus 3 by 3 plus 5 by 2. Right? So I'll finish with the first row and first column. Now, second row, 2 by 3, 0 by 2. Okay? So that'll be minus 9 plus 10, which is 1, 6 plus 0, which is 6. Okay? Yeah? What's that? Let's go. All right, so right. Let's change it again. Let's go a little bit harder. Right. What's the rule again when multiplying? Multiply the rows in the first matrix by the columns in the second, right? So I'm going to give you a 2 by 2 now by a 2 by 2. Yeah. Right. Are they conformable? Are they conformable? Yeah. A 2 by 2 by a 2 by 2 is conformable, right? So watch this here, right? What's the answer for 2 by 2 by 2 by 2? 2 by 2, right? So I'm supposed to get 4 values. 1 to be kind of watching here. 1, 2, 1, 2. Right? So I'm supposed to get 4 values, right? That's okay? So you're doing 4 steps of multiplication. So you're doing row by all the columns, row by all the columns. That's okay? So you're doing this row by this column. That'll be your first answer. And you're doing this row by this column. Right? So it's by the first row by all the columns. That's okay? And then you finish. That'll be your first 2 values. Then you come down here now. Second row, these 2 columns. So you're doing this by this, this by this. And you'll get the last 2 values here. Right? Those who follow, try it. Those who don't, wait a 2 minutes and I'll do it. Right? So it's row by column, right? Are you ready? So watch this here, right? So you're multiplying row by column. First row by the first column. So it's 4 by 2, that's 8. Plus 5 by 4, that's 20. So it's this by this. 4 by 2 is 8, 5 by 4 is 20. Okay? I'm done with the first row and the first column. Done with the first column actually. Now first row, second column. 4 by minus 4. Sorry, 4 by minus 1, 5 by 0. Right? So I took the first row and I multiplied by 2 columns. That's okay? So I finished with the first row now. So I did the first row by all the columns. Now I'm going to the second row and all the columns. 3 by 2, that's 6. Minus 2 by 4, that's minus 8, right? Row by column. 3 by minus 1, minus 3, minus 2 by 0, 0. So the final answer is 28 minus 4 minus 2 minus. See that? Don't see that? I'll show you one more time. Row, first row by this column. First row, second column. So you're multiplying this row by all the columns you have here, right? Then you're done. You finish with that first row. The second row of values here now comes from the second row, right? So your first row giving you your first row of values. Your second row giving you your second row of values. So there be 3 by 2. So this row by this column, that's this value here. This row by this column, giving this value here. Right? Copy it down. Let's go again. Try that again.
Anybody else? Right, straight, like.
So let's check this multiplication out and see what. Also, I do it already. Nice man. I do. Right. So let's take row by column. 3 by 2 is 6 minus 2 by 5 minus 7. Row by column 3 by 4 is 12 minus 2 by 1 is minus. Row by column minus 1 by 2, 2 by 5. Very good. Minus 2 by 4, 2 by 1. Right? So 6 minus 10 is minus 4, 12 minus 2. Very good. Right? So that's the way you multiply. Right? Let's do one more. Right, try this here. Take your time, huh? Check and make sure it's conformable first.
Yeah.
This one a little bit trickier, right? Oh, Anya said you had something wrong. It will be minus 8 by 2. Where, Anya? Here? But that's not, unless Anya have the last part wrong there. Yeah. So this is minus 4, 2. You sure, Anya? This is minus 1 by 4, 2 by 2, right? I think they're correct.
No, sir. Minus 2 by 4 is minus 8.
What's that? I'm not hearing you.
Minus 2 by 4 is minus 8.
Where you have
Not
that?
minus, right? Yeah.
So 3 by 2 is 6, minus 2 by 5 is minus 10. Go by column, it's 3 by the 4, minus 2 by 1. See enough? So you do have 4 by minus 2 anyway. That's okay? Yeah, so it's this by this, it's 3 by the 4, minus 2 by the 1. Right? 3 by 4 is 12, minus 2 by 1 is minus 2. Okay, that's all right. Try this next one here. It's a little tricky. Can you multiply it?
Yes, and I'll be actually by 1 minute to get the answer.
Or we have 3 by 3. Because you have a 3 by 1 here and a 1 by 3 here. These two are the same, so your answer is a 3 by 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. That's number here, don't matter. Try that for now. Work it out. So it's supposed to get 9 values, right? Supposed to get 9 values, right? Right, let's see how this one. Right, so you're multiplying. Watch, you have all your rows here: row, column, right? Same. So you're multiplying 1 by 2, right? And you're done. That's it. This row by this column is 1 by 2. Then this row by the column is 0. Then this row by the column is 3. That's okay? That's it. Nothing else. Second row now. Right? Always remember, these rows will give these values. So this first row giving you all the values here. This second row giving you all your values here. Third row giving you all the values there, right? 5 by 2, 10. 5 by 0, 0. 5 by 3, 15. 3 by 2, 6. 3 by 0, 0. 3 by 3, 9. That's the answer. There we go. Online, are you okay with that? Anya, you okay with that there? Ravina? I started going to learn too, but I can't remember. But let's look, there's a way to input the matrices and then put multiply. So you gotta go under matrices, put in the size, and then there's a function to multiply. But I don't use it now. So I had to go back and during the holidays, I'll probably do a video on it. So I won't have to remember again. Yeah, I could do a quick TikTok on that. All right, let's go back to the summary. We're done with multiplication. Everybody okay with multiplication? All can multiply, Piavi, all can multiply. Right, last thing we want to learn to do today is finally determinant. Hold on, why is this taking so long now? Right, so we learn about multiplication. We have 3 rules to learn. Last thing that we have to learn to do is find the determinant, right? And we're done for today. I'm not doing simultaneous, right? We'll do some past papers after this. Right, determinant. Determinant gives you an idea of the magnitude of the matrix, right? Take a look up here. Right? Determinant gives you an idea of the magnitude of the matrix. But at this level, we could only find determinant for 2 by 2. Right? To find determinant, which is the magnitude, you multiply A by D, B by C, and subtract values. You're seeing that there? Look at the simple example underneath. Right? 2 minus 1, 3, 4. Its determinant is 2 by 4 minus 1 by 3. Okay, so, and they got 11. If by chance you work it out and you get the determinant to be 0, that matrix is said to be singular. Okay, if the determinant is not 0, then it's a non-singular matrix. All right, so watch this example here. If you look at the example here, the question said that the matrix was singular. So it meant that the determinant here is going to be 0. So if you work out the determinant, 2 by 1, that's 2. P by 3, that's 3p. And you minus them, then based on the question, it said that the determinant is 0. So it means that 2 minus 3p is 0. You can make 3p the subject. P is equal to 2/3. That's okay? So that's the way you find your determinant. And last thing, actually, try one here for me. Find the determinant of A. 2, 4, 5, 1. Find the determinant real fast. You can do that mentally. What's the determinant of that matrix? Eight, sure, minus 18, right? So it's 2 by 1 minus 4 by 5. So that's 2 minus 20, which is minus 18.
All by 18, eh?
Huh?
All by 18.
No, we reach here yet. That's when you find in the inverse. The determinant is minus 18. Try the next one. B is equal to 4, 2, 8, 1. Tell me what you get. How much you got? 0. So what type of matrix is that? Singular, right? So that's 4 by 2 minus 8 by 1. So that's 8 minus 8, which is 0. Okay? So that matrix is singular. All right? Nice. Let's go in reverse. I'm going to tell you it's singular and I want you to solve P from it. Okay. Right, so if B is singular, find P. Find P. Hey, if you all go downstairs, don't touch your walls on there. The paint in some of the rooms, right? Or you can go in the on the chair outside. Right?
Anything to do with B, that you
And when you ever see you, and I was saying anybody. Work it out about what you get for P. Those who online message your answers. What you get? What you all get? P. I got you. And me too. Yeah. You'll get a break just now. So 3 by P just now. 3 by P minus 2 by 6 is equal to 0. 3P minus 12 is 0. 3P is 12. 12 is 4. Right? Last question. Yeah. Yeah, you have 15-minute break here in between 1-5. It'll be a little more sometime according the first few days, the break in between. About that here. Might be a little longer on the latter days, but the first few days will be kind of hard. Because I do only have the longer topics. Right. One past paper and we done, right? No, I don't have time for that. All night doesn't think we will do that. Right, let's do B, C part 1 and 2. What year is this? June 2016. Right, forget this and forget it. Oh yeah, last question, are we done, right? You're doing B and C part 1 and 2. What happened? Come on, question, huh?
Anything now, I'm going
All right, let's go. That's correct. It's out. All right, let's start. And the first one, so 3 by 4 is 12 minus 2x is equal to 0. So x is 6. You all got that?
Yes.
Right, then when you multiply 4132 by 1521, when you multiply that, you'll end up with 4 plus 2, that's 6. 20 plus 1, that's 21. 3 by 1, sorry, yeah, 3 plus 4, that's 7. And then 15 plus 3 is 8. Sorry, 15 plus 2 is 17. That's okay? Are you okay with that? So, right, that is when you multiply NP, right? When you multiply PN, you're getting something totally different. What does that mean? That means that it's not commutative, right? That's all you had to say. NP is not equal to PN. Therefore, it is not commutative. All right, so that's it, right?